Welcome to section 4.2, lesson 1. Here we'll be looking at line graphs and something called interpolation and extrapolation. Let's first define trend. That is the general direction in which values in a data set tend to move. Trends are either upward, positive, or downward, negative. So this graph on the left, as time increases, the distance increases. So this is an upward trend. And for this other graph, as time goes on, the population decreases. So this is a downward trend. Now extrapolation is an estimate of a value that falls outside a known range or a graph of values. So for example, if the trend continues, what will the next values on the graph likely be? So you extend your graph and then you estimate. Now interpolation is an estimate of a value that falls within a known range or graph of values. So if you have the points 3 and 4 plotted on your graph and you want to know the value at 3.3, that would be interpolation. So example 1. The following data represents the sales of an online store in millions of dollars from the year 2000 to 2018. Now what trend do you see from 2000 to 2018? Well, as time goes on, the sales increase as well. So we have an upward trend here. So we can say that sales have increased every year since 2000. Now estimate what you think the sales were in 2017. So this is 2017 right here. So let's go straight up and then straight across. Now this is just slightly above $3 million. Now the point above that is 3.2, and this is not quite halfway, so I'm not going to say 3.1 million, I'm going to say 3.05 million. Now in what year did sales reach $2 million? So let's start right here, go across, and then go down. That is the year 2007. Now use a ruler to draw a line going through the middle of the graph, and we call that the line of best fit. And then extend the line beyond the data to predict the amount of sales in 2022 and what year the sales will reach 3.5 million. So using a ruler, draw a line through as many points as you can and try to have an equal number of points above the line and below the line. So here's my line of best fit here in black. So now I'm going to predict the amount of sales in 2022. So that's right here. So if I go straight across, that looks to be 3.6 million. Now in what year will sales reach 3.5 million? So that is in between this line and this line. So say right here. If I go straight down, I say that's close to 2021, somewhere in that year. Now what process did we just use in part D? Well, because I extended the line and then I estimated, I just extrapolated. So we used extrapolation. Now example 2. One factor which determines a crop yield is the amount of fertilizer used. So this is a similar example to one we looked at before. Now the graph below contains data for two separate crops in two different regions. So the red line, the one with the circles, we'll call crop A, and the green line, the one with the squares, we'll call crop B. Now on the bottom we have the amount of fertilizer used, and on the y-axis the crop yield measured in tons. Now it says compare and contrast the trends in both crops. Well, they both have an upward trend. They're both increasing as the amount of fertilizer increases. So both increase. But now let's compare crop A with crop B. I'm going to say that crop A starts off less than crop B, but then after it ends up higher. So I'm going to say crop A starts off less than crop B, but increases much faster. Than crop B. Now, when does crop A yield more crop? Well, in the beginning we said it's less, and at this point right here, at 40 kilograms, they yield the exact same amount. But then after that, the red line here, the crop A is higher. So after 40 kilograms of fertilizer, that's when crop A yields more. Now, just say you only have 50 kilograms of fertilizer. Which crop would you place it on? Well, 50 is right here. If you go straight up, crop A is higher. So let's say that crop A yields more crops than crop B. So you should choose crop A.